The lines in a covalent structure are bonds. These bonds contain how many electrons? So each line, you can draw them like this as well to help you remember. Each line contains 2 electrons. Sulfur can form how many bonds? This is going to be dependent on how many empty, lonely electrons sulfur has. Sulfur is in column 6. So if I was to draw the Lewis structure for sulfur, it would look like this. I have 2 lonely electrons, so I can form 2 bonds. Nitrogen can form how many bonds? This is going to depend on how many lonely electrons nitrogen has. Nitrogen is in column 5, so if I was to draw the Lewis structure for nitrogen, it would look like this. Nitrogen has 1, 2, 3 lonely electrons, so it can form 3 bonds. Carbon can form how many bonds? This is going to depend on how many lonely electrons carbon has. Carbon is in column 4, so that means it is going to have 4 valence electrons. If I was to draw the Lewis structure for carbon, it would look like this. So I have 1, 2, 3, 4 lonely electrons, so I can form 4 bonds. Hydrogen can form how many bonds? This is going to depend on how many lonely electrons hydrogen has. Hydrogen is in column 1, meaning that it is going to have 1 valence electron. So if I was to draw the Lewis structure for hydrogen, it would look like this. Hydrogen has 1 lonely electron, so it can only form 1 bond. Fluorine can form how many bonds? Fluorine, this is going to depend on how many lonely electrons fluorine has. Fluorine is in column 7, which means that it is going to have 7 valence electrons. So if I was to draw the Lewis structure for fluorine, it would look like this. Fluorine has 1 lonely electron, so it can form 1 bond. A lone pair of electrons contains how many electrons on the same side? A lone pair, is going to be 2 electrons. So any lone pair is going to be 2 electrons that are on the same side of that Lewis structure. The largest number of bonds that can form between 2 elements, this is going to be a maximum of 3. Past 3 electrons, you are going to have too tight of a bond angle, and those electrons are going to repulse from each other too much to withstand it. So 3 is my natural maximum number of bonds that any 2 elements can form between themselves. So 1 element plus 1 element, max 3 bonds. Draw a Lewis structure for CCl4. So first I'm going to go ahead and I'm going to write out all of the members of this compound. CCl4, I have 1 carbon and then 4 chlorines. Then I'm going to go ahead and distribute my dots. Carbon is in column 4, so it's going to have 4 valence electrons, 4 dots. Chlorine is in column 7, so it's going to have 7 valence electrons or 7 dots. So I'm going to go ahead and distribute those to all of my chlorines. And now I'm going to go ahead and start bonding. I'm going to go lonely electron to lonely electron. And I'm going to try by starting by connecting everything to my least electronegative element. That's the one that comes first. That's going to be carbon. So I'm going to go ahead and I'm going to try to connect everybody to carbon at least once. When I do that, I can see that no lonely electrons are left and everybody got included. So that means that that's going to be a structure that I can move forward with. So I'm going to redraw the structure nice and pretty. And I'm going to redistribute all of the leftover lone pairs. So each chlorine had 3 lone pairs that were not involved in bonding. So I'm going to give those lone pairs back to chlorine. Now we can start answering the question. So it has how many electron pairs? How many bonds? I have 1, 2, 3, 4. I have 4 bonds. Who is in the center? Carbon. Carbon is in the center of the structure. Carbon has blank blank bonds. So this is going to be a number and then the type. So I have 1, 2, 3, 4. So I have 4, and then the single line is a single bond. So I have 4 single bonds. Each chlorine has how many lone pairs? Each chlorine has 1, 2, 3, 4, 5, 6 total that are not bonded, and they are in pairs. So I have 1 lone pair, 2 lone pairs, 3 lone pairs. So that is going to be, each chlorine has 3 lone pairs. Draw the Lewis structure for H2O. So first I'm going to go ahead and just draw out everybody that was listed in the compound. So I have 2 hydrogens and 1 oxygen. Hydrogen is in column 1, which means it has 1 valence electron. So I'm going to give 1 dot to each hydrogen. And then I can move on to oxygen. Oxygen is in column 6, so that means it's going to have 6 valence electrons, 6 dots. And then I'm going to go ahead and start connecting my lonely electrons. I'm going to make sure that everybody is involved. If I bond hydrogen with hydrogen, then those hydrogens can't form any more bonds and oxygen is left out. So I'm going to go ahead and I'm going to bond hydrogen with oxygen, lonely electron to lonely electron. When I do that, I see that there are no more lonely electrons left, so that looks good to me. So then I'm going to go ahead and I'm going to redraw this structure. And redistribute the the lone pairs of electrons that were not involved in bonding. And oxygen had 2 lone pairs in the ugly structure, so it will get those 2 lone pairs back in the pretty one. Now I can start answering my questions. It has blank number of electron pairs. My electron pairs are going to be my bonds, and I have 1, 2 bonds. I have 2 bonds. Blank is in the center of my structure. Oxygen. Oxygen is the one that everybody's paying attention to. So oxygen is in the center of my structure. Oxygen has blank blank bonds. So this is going to be a number and then the type. So oxygen has 1, 2, and then this is a single line, so this is a single bond. So I have 2 single bonds. Each oxygen has how many lone pairs? Oxygen has 1, 2 lone pairs. And each hydrogen has 0. I didn't draw any. I didn't have to redraw any from the original structure back here, so it's going to maintain at 0 lone pairs.